Hello, welcome to this video that goes through questions 6 to 10 of exercise 7D of the Edexcel AS textbook, and this will be going through some more proof questions. So the first one we've got proof that the solutions of x squared plus 2bx plus c equals 0 are x minus b plus or minus the square root of b squared minus c. So for this way here we can probably use completing the square for this one, although you could use the quadratic formula as well. So I suppose you've got two ways of proving this one. So if you use completing the square, again, the general formula for completing the square is x plus b over 2 squared minus b over 2 squared plus c, where it's ax squared plus bx plus c. So to use the method of completing the square, we could just say it's x plus, then it's 2b divided by 2 squared minus bracket 2b over 2 squared, and then plus c, and that's equal to 0. And then we can so expand this, so we can simplify it. So 2b over 2 is b, so x plus b squared minus 2b over 2, so that's minus b squared plus c is equal to 0. From here we can move, let's move everything to the right hand side. So we got x by itself, so it's x plus b squared equals b squared minus c. And then we can square root both sides, so it becomes x plus b equals plus or minus the square root of b squared minus c. Then we can subtract b, so x equals minus b plus or minus the square root of b squared minus c. Again, for this one, there's no, so in terms of my approach to this question, you could also do the quadratic formula as well to prove it. There's nothing to say that you can't use that. The answers themselves use completing the square, but the quadratic formula, x is equal to minus b plus or minus the square root of b squared minus 4ac over 2a, and you could plug in the answers here. So it's going to be minus 2b plus or minus the square root of 2b squared minus 4 times 1 divided by, oh not 1, sorry, we've got c, so minus 2b squared minus 4 times 1 times c divided through by 2. And then from here, if we solve inside the bracket, it's plus or minus the square root of 4b squared minus 4c divided by 2. And then we can take out a factor of 4, so it's minus 2b plus or minus the square root of 4b squared minus c divided by 2. Take out a factor of 4, so we can do that by saying root 4 root b squared minus c, and then root 4 is 2, so that becomes 2b squared minus c. So it's minus 2b plus or minus 2 root b squared minus c divided by 2, and then if we divide by 2 we get minus b plus or minus the square root of b squared minus c. So that's your alternative way using the quadratic formula. Again, make sure you show every single step in this question. Question 7, prove that x minus 2 over x cubed is equal to x cubed minus 6x plus 12 over x minus 8 over x cubed. So for this one, you could do, I suppose you could do the binomial formula, but I wouldn't do that one. I would just expand the bracket step by step. So x minus 2x in brackets, so that's the same as writing it out, and then we just go through step by step. So the first thing we got is, we'll do this bracket, the first two brackets together, so that's going to be x squared, then x times minus 2 over x is equal to minus 2, and then minus 2 over x times x is equal to minus 2, and then 2 over x times 2 over x is equal to plus 4 over x squared. So that just leaves you as x squared plus 4 over x squared minus 4, and then we're going to multiply that by x minus 2 over x. So the next thing that we do is we're going to do x squared times x, which is x cubed, then x squared times minus 2 over x, which is equal to minus 2x. Then the next one we do is 4 over x squared times x, which is equal to plus 4 over x. And then we've got 4 over x squared times minus 2 over x, which is minus 8 over x cubed. And then finally we've got minus 4 times x, which is minus 4x. And then we've got the last one, which is minus 4 times minus 2 over x, which is plus 8 over x. From here we combine like terms together, so we get x cubed minus 2x minus 4x is minus 6x. 4 over x plus 8 over x is 12 over x. And then finally we've got minus 8 over x cubed. And then we check back our answer and we can see that that matches our result. So that's our answer for question 7. Question 8, prove that x cubed minus 1 over x times x 3 over 2 plus x minus 5 over 2 is equal to x power of a half x 4 minus 1 over x4. So this one's got a lot of indices going on here, so I would rewrite everything, well, rewrite this term here, 1 over x is equivalent to x to the power of minus 1. So we've got x cubed minus x to the power of minus 1 times x 3 over 2 plus x to the power of minus 5 over 2. And then here we need to remember our indices rules. So if you've got xa times xb is equal to xa plus b. So from here, well, first one is going to be x cubed times x 3 over 2 is going to be x cubed plus 3 over 2. And then we're going to do x cubed times x to the power of minus 5 over 2. So it's going to be plus x3 minus 5 over 2. And then we move on to our next one. So it's going to be minus x minus 1 plus 3 over 2. And then our final one that we have is going to be minus x minus 1 minus 5 over 2. From here we plug in our answer, so it's going to be x, which is going to be 4.5 plus x, so 3 minus 2.5 is going to be x to the power of a half. And then we've got minus 1 plus 1.5, which is x to the power of 0.5. And then x minus 1 minus 2.5 is minus 1 minus 2.5 is minus 3.5, minus x to the power of minus 3.5. So then from here we can put these together. Oh yes, so I've made a small mistake here with the sign. So here then this should be a negative value here because it's minus x minus a half 1 plus 3 over 2. So what happens is that these two cancel out and you're left with x 4.5 minus x to the power of minus 3.5. And then we can take out here a common factor. So if we take out, so if we look back at our question, it wants us to take out a power of a half. So we can take out a power of a half by saying that this is the same as x 0.5 x to the power of 4. And then here, this one is quite a tricky one. So here it's minus x to the power of 0.5. And then we want to get back to minus 3.5 because we want to keep it the original 1. So here is going to be minus 4.5 here. Minus 4, sorry, not 4.5. So it becomes minus 4. So minus 4 plus 0.5 is minus 3.5. And that's how we can pull out our x to the power of 0.5, x to the power of 4 minus x to the power of minus 4, which is the same as x to the power of 0.5, x to the power of 4 minus 1 over x to the power of 4. So again, this part here is just using our indices rules, so x to the a times x to the a b, x to the a times x to the b is equal to x to the a plus b, but we use the inverse of that, so 0.5 plus 4 is equal to 4.5, so we can pull that out individually, and the same here, 0.5 plus minus 4 is equal to minus 3.5. And that's how you get your result for this question. Question 9, use completing the square to prove that 3n squared minus 4n plus 10 is positive for all values of n. So the first thing we do is we complete the square, so here we've got a 3n squared minus 4n plus 10. So to complete the square, we need to ensure that we always have an x squared plus bx plus c format. So here we're going to take out a factor of 3 from the first two terms. So it becomes 3n squared minus 4 over 3n, then plus 10. And this allows us to complete the square just for this section here. So if we complete the square here, it becomes 3 bracket bracket n minus 4 over, and then we divide it by 2, so 4 over 6, n minus bracket 4 or minus 4 over 6 squared, not n, sorry, the n cancels out, so 4 over 6, and that's the squared there, and then close bracket plus 10. And then from here we continue through, so we say that this is 3 bracket bracket n minus 4 over 6 all squared, and then minus 16 over 36 bracket plus 10, and then we bring this out by timesing it by 3. So we times this by 3 to bring it outside the bracket, so it becomes 3n minus 4 over 6 squared minus 3 times 16 over 36 plus 10. And then from here we say this is 3n minus 4 over 6 simplifies down to 2 over 3 squared, and then we just plug into our calculator what minus 3 times 16 divided by 36 is, and then plus 10 to the answer. So minus 3 times 16 divided by 36 plus 10 is equal to 26 over 3. So plus 26 over 3. So what does that mean? Well, it means here that we have, so if we use completing the square also gives us a minimum point, and we want to prove that essentially 3n squared minus 4n plus 10 is positive for all values of n. So it's saying that if n is on the y-axis, if n is on the x-axis, then all the y values here, all the results are going to be positive. So essentially it means that it doesn't cross the x-axis. So here we need to find, we can use this to find what the minimum point is. To find the minimum point, we change the sign of this from minus 2 over 3 to 2 over 3, and then we keep the y value. So it's going to be 2 over 3, 26 over 3. So its minimum point, for example, is somewhere here, where this is 2 over 3 and this is 26 over 3. And that's your final answer for this question. You've proven that essentially the minimum point is a positive, so the min point has a positive y value. So therefore all n values are positive. Let's move on. So use completing the square to prove that minus n squared minus 2n minus 3 is negative for all values of n. So let's start with our equation. So minus n squared minus 2n minus 3. The first thing we do is we take out a negative 1 from our first two terms. So it's negative 1 essentially, n squared plus 2n close bracket minus 3. From here we complete the square just of this section here. So it's minus 1 n squared plus 1 squared minus 1 squared close bracket minus 3, and then this simplifies down to minus 1 bracket n squared plus 1 squared minus 1 minus 3. To pull this one out, we times this by minus 1 because that's the number in front of our bracket, so that becomes minus n squared plus 1 squared. Minus 1 times 1 is plus 1 minus 3. So it's minus n squared plus 1 squared minus 2. Then from here we do exactly the same. So this time we're finding a maximum point because it's a negative n squared graph, or negative x squared. And again we change the sign here, so from 1 goes to negative 1, and our y value stays the same at minus 2. So therefore the max point is at y equals minus 2. So therefore all y values are negative So therefore all n values result in a negative answer. And that gives you your answer for these questions. If you have any further questions, please let me know.